In this video, we are going to look at these three examples. Solve the following using the appropriate substitution. So that's how fast the question is. Do not tell you we know that the appropriate substitution can be separable, it can be homogeneous, it can be equation, you reduce it to homogeneous or non-homogeneous, right? So you have to check whether it is falling on the right time. Very good. So let's go straight to the point. You know that the whole of this is what? Non-homogeneous because the constant in, and also here I'll tell you later. Very good. Now, yeah, but it's homogeneous because I will give it to you in the proper form. Then you see how it is and how to go about it. Alright, so you can see that in this question we have an initial condition given. Alright, so that means that in the first question we are not supposed to leave it in the general solution but rather a particular one solution because at the end of it all we can use the IDP to get the constant what? C. Very good. So let's start. Let's start with the first one. I would like to clean it. Let's start with the first one. So with the first one, we start by first. We know that this is not homogeneous, but let's check something. Whether A1 over A2 is going to be B1 over B2. So this A1 is the coefficient of the X. Alright? And the coefficient of the X on top is what? 3. A2 is the coefficient of the X down, which is 3. B1 is the coefficient of the Y is 2. The coefficient of the Y here is 2. Oh, so that means that here is 3 over 3, here is 2 over 2. It means that this is equal to this. So this question fall under case 2. Fall under case 2. Don't forget, it's not case 2 because here is 3, here is 3, here is 3, here is 3, here is 2. No. Even if you get half is equal to half, the idea is that the whole of this is equal to this. Is that clear? Very good. So here we see that by this analysis, we can see that the question fall under the case 2. The case 2. So how do we do the case 2? Straightforward. This is not about S1, this is not about Y1, this is not about anything. Let's go straight to the point. Alright? So yeah, then you can notice something that what is here is the same as what is here. So we let Z to be equal to 3x plus 2y. So by substitution, then, but before you do the substitution, you have to do something. You know that you are going to substitute this. Wherever you see this, you are going to put Z there. Wherever you see, you are going to put Z there. So you have to change this divide here. We have to change this divide here. Because we are going to do the substitution. You watch something. The y dx is going to be Z over Z plus 2. How can you take the derivative as respect to x, whereby this is the term of this? So we have to rewrite it well again. So right after setting Z to be equal to this, then we take the Z as respect to what? X. So we take the determinant of Z as respect to X. And when you take the derivative of this, you get 3. Plus the derivative of this, you know it's going to be implicit. So 2 dy dx. Alright. So now that we have this, we do the substitution of this equation 1, this equation 2, back into this. So yeah, the whole of this. Before that, know that we have to make dy here the subject so that we can do the substitution into here. So here we get dz over dx minus 3 is equal to 2 dy over dx. So I don't forget my initial condition. Let me write it here. So here we get 2 dy dx to be equal to dv dx minus 3. Then we divide both sides by 2. And when you divide both sides by 2, then we are going to get something like, or you can multiply both sides by half. Multiply this by what? Half. So this cancel this. Exactly. Then we get dy dx to be equal to half dv dx minus 3. Alright. So by substitution, dy dx is that. I hope you can see that. So we get half dv over dx minus 3 is equal to, and that is dy dx. I hope you can see that. That is dy dx. That is it. Then here this is it. Don't forget this is case 2. This is case 2. Case 2. So here we get z over z plus 2. So you can see that everything is in terms of what? Z and x. So we are now transforming into a separable differential equation. So here, what can we do? We want to remove this fraction. So what can we do? We can multiply both sides by 2. So we get dv over dx minus 3 is equal to 2z over z plus 2. We have multiplied both sides by 2, and that is what we have there. Then we are going to make dz dx the subject. We want it to stand alone. So we get dz dx to be equal to 3 plus 2z over z plus 2. Alright? And the next idea is that you can see that everything here is in terms of what? X. Alright? Sorry. It's in terms of what? Z. So to make it separable, let's try to achieve the same denominator. So dv dx, oh I love this question. 3z plus 2 z plus 2 plus 2z z plus 2. So we get the same denominator. So 3z plus 2 plus 2z, all this over z plus 2. Then we can get dv over dx to be equal to 3z plus 6 plus 2z, all this over z plus 2. You can see this is not about s1, y1 or whatever. I hope it's clear. Alright. So here we can do something to it. Oh. Let's move on. Don't forget that you can let this be equal to this. We will come back to it to use it later. Alright? We will be using this later. So now, here we can get dz dx to be equal to 5z plus 6. 5z plus 6 over z plus 2. Z plus 2. Now you can see that this is separable. And if it's separable, then let's go and solve it by a separable differential equation. Alright. So, I hope you are done with this part. So, here we can write as dv, let me write it here. dv is equal to dx. Okay? Now, here is in terms of z. So we reciprocate this. Z plus 2 over 5z plus 6. Then, you know, the x is just going to be 1. The x then is just going to be what? 1. Alright. Then we take somewhere. Let me check something here. Oh, let's continue. Very good. So now, here we move on. So we integrate both sides because we now have a reciprocal differential equation. We know this is going to be as respect x, then x plus c. That is established. Let's come to this side. Calculus 2! Welcome. So how will you do this? With your calculus 2. We use plates. We go by that. Here you can do it as such. If only you know what you are doing. So this is z over 5z plus 6 dz plus integral of 2 over 5z plus 6 dz is equal to this. But you can't forget this side. Okay, we'll come back to it. We know that here, what technique will you use to solve that? What technique will you use to solve that? We know that here is just going to be, this side is just simple, alright? This side is just simple. Alright, very good. But here, you can see that, oh, let's look at this side. Here we can bring 2 out, 1 over 5d plus 6 dv. This is just truly, how do you see that? It's going to be truly, but don't forget, the coefficient here will come and divide what is here. So 5, so 2 over 5 means 5d plus 6. You know your technique already. So this, the result for this side, okay? So this is equal to this. Is equal to s plus c. But what about this side? Don't forget that here, what we have here is improper. And why is it improper? We can see that it's improper because here is power 1. Here is power 1. So this is what? Improper. So you can solve it in the idea of what? Improper. Alright? Very good. Sorry. So when you solve it with the idea of improper, you know the steps you go by. This becomes a divisor, this becomes a dividend, then you do that. In all, you are going to get something like, I want to go straight to the point. So when you do that, you're going to get 1 over 5z plus 1 over 5z minus 1 over 6 ln 5z plus 6. Alright? Go and solve it as that. Because if it is improper, I don't want to be doing that for you. If it's improper, then we know that here this is our what? Dividend. 5z plus 6. This, sorry. Dividend is z. Divisor is 5z plus 6. Alright? So this divided by this, then you come back to it, you come and integrate both sides. Alright, you come and integrate, you are going to get 1 over 5 minus, then like that. 5 over 6, multiply 1 over 5d plus 6. Then you integrate both sides. And when you do it, you're going to get it. I'm not doing that for you. Alright. So this one you're going to get. But here you have to go and do the substitution back. So but we change back. When you solve this, you are going to get this. Alright. And you can do this, as I said, by improper, by transforming it into improper fraction. And when you take it to improper fraction, then you come and write this improper is equal to what? Remainder over the divisor. Then you don't forget that you write the quotient plus remainder over the divisor. Then you come and integrate what? Both parts. Very good. So when you integrate it, don't also forget that when you do it, that your remainder is going to give you negative 6 over 5. Then the quotient, you're going to get it to be 1 over 5. Alright, so you can try on that. And when you integrate, you get this. Then this one will give you this. This part is what we have. But don't forget that we know that z is equal to this. So from the interval given, that is this, your x is -1, your y is -1. Very good. So by substitution, we can get the z. Alright. So here you get z to 5. Do substitution to this. You get z to 5. Then you come and do the substitution to here. Wherever you see z here, put 1 there. 5 there. And when you put 5 there, please, it's the same as you replacing back the z here. But that one is going to be point of start. When you replace back the z here, this is going to be in terms of only x and what? Y. Then you replace x by -1, replace y by -1. That is from the interval given. Alright. It's going to give you the same answer as 3. But when you first find z to be 5, and you go and do the substitution here, you see that the x here, you replace it by the -1. And that is also going to give you the answer of what? 3. So the same thing. Very good. Then, after you are done, then you come and replace the c back, which is 3. So this becomes your particular solution. But please don't forget, you have to replace the z by 3x plus 2y. Don't leave the z inside there. So I leave that for you to do it. The z, replace it by 3x plus 2y. The z here 3x plus 2y. The z here 3x plus 2y. And that is what you are going to get for that. Very good. So that ends the A part of the question. So let's look at the B part. So I would like to clean this. You see, it's not difficult, alright? It's just steps. Alright, so don't forget, you can play back the video about 3 times and you'll be familiar with it. Let's look at the B. Straightforward. Now, this B here, you can, even though the question leads to you in this form, but you can also get it in this form. Watch me well. You see, when you do cross multiply, you can get it as x plus y dy is equal to x minus 1 minus x minus y dx. Okay? You can get it in this form. Even sometimes you can get it as x plus y dy minus, saying this one here, 1 minus x minus y dx is equal to 0. Getting it this form is the same as getting it this form, and the same as this form. Okay? So don't be confused. It's still the same thing. Alright? But don't forget, when you are given in this form or this form, you have to transform back to this form. In what way? It's just simple as that. Just the idea of making the y dx the subject. So you just divide both sides by dx, okay? So when you divide both sides by dx, then it's like this. When you divide by dx, you get dy dx. Then you divide both sides again by x plus y, so that you come back to it. So don't be confused there. Because it's only in this way that you can get the idea of solving it fast or straight away. Very good. Let's move on. So here, first of all, the constant introduced here is telling you that it is non-homogeneous differential equation. Another idea is also that if this is non-homogeneous differential equation, then is it case 1 or case 2? Okay, the coefficient here is -1, the coefficient of x here is 1 is equal to, the coefficient of here is -1, the coefficient here is 1. Oh, -1/1 is equal to -1/1, so this is equal to this. So this is straightforward, a case 2 question. This is a case 2, and if it's a case 2, then we have to get something which is, we have to get something in the numerator here, which is the same as the one in the denominator. So how do we get that? Looking at the first question that we saw, it was straight away there. Okay? For that one, it's easy to see it, because we have something like 3x plus y, and here is 3x plus y or 2y. No problem. Something like this. You can see this is the same as this, without any factorization or anything. But looking at this, we have to do something first. And what is that? Simple algebra. We can see that here, we can factor the negative out. And when we factor the negative out, we get minus x plus y. Don't forget that writing the numerator as this is the same as this. Because when the negative appears, you get negative x, negative y. I hope you can see that. Very good. Over x plus y. So you can see that we have x plus y here, x plus y here. So the question becomes what? Simple as that. Then we let case 2, oh, don't forget, case 2. So we let z to be equal to x plus y. Then right after setting z, differentiate as respect to what? X. So dv dx is equal to 1 plus implicit. So y dy dx. Right, so that's that. Then we make dy dx the subject. Okay? I want you to check this one well. Is there any mistake? 1 y dy dx. Alright. That's that. Oh, sorry, no. This one won't come in. Inflated. So we get differentiate y, we get dy dx. So we have dv is equal to 1 plus dy dx. So by making dy dx the subject, so that we can come and do our substitution, we get dy dx is equal to dv dx. Okay, so dy dx, let me do it here. Okay, so we get dv dx, send this one here, minus 1 is equal to dy dx. Very good. So wherever you see dy dx, we have put the whole of this there. So with this, we get dv dx minus 1 is equal to this. And this is 1 minus, this is what? Z. So z over, the down is what? Z. So this is z. Very good. So now we can get dv dx is equal to 1 minus z over z. Send this one here, you get plus 1. So we go on because we are now transforming the non-homogeneous to homogeneous. And when you get to homogeneous, then you take it to separable. You see how it is? Very good. So now, to get it in the separable form, we have to maintain the same, we have to get the same what? Denominator. So 1 minus z over z plus z over z. It helps in maintaining the same what? Denominator, because it is what? So dz over dx is equal to z minus, 1 minus z plus z, all this over z. Don't forget, 1 is the same as z over z. Oh, easy. Hope you can see it. Bam, bam. So dz over x is equal to 1 over z. How can we do this in separable? So here we get dz dx. So here we get the z will come here. Like cross multiplication, z will come here. This will go to this side. This one is here is 1. Integrate both sides. Oh, this question is just simple. Alright? And then I'll come back to minutes to make sure you write that part. Okay, so when you integrate this, what will you get? Okay, so when you integrate as respect to z, you get z squared over 2. That is all. It's equal to, here we get x plus c. Wow, I love this question, I love this question. So here, then after here, what will you do? What will you do? What will you do? There is nothing to do. The only thing to do is to go exactly back to the z. So what is z? X plus y. So back. So don't forget that in this question there was no initial condition given. So we are going to leave it in the general solution form, not particular solution. So here is x plus y. So by replacing x plus y squared over 2 is equal to x plus c. That is the end of this solution. It's not difficult. Make sure you try and answer more questions, and I will be giving you more questions for you to go and try. Oh, my laptop is off. I'll be giving you more questions for you to go and try. Alright? Very good. So let's move on to our next question. Alright, so let's try our hands on this question. Now let's examine to see the type of equation it is, or the method that we can use to solve this equation. What method can we use to solve this equation? I may not end some minutes, but I want to discuss something with you. So whether to check whether it is homogeneous or not homogeneous, let's check on something. In fact, let me tell you. There is no concern in it. Then it will not be, it will be homogeneous, but not homogeneous. Or equation reducible to homogeneous equation, it will not be that. Let's see, new lesson. We can write it as s dy dx minus y is equal to y. With this, you can write it as ln y over x. How you can see that? Very good. So having this, then we can, in fact, you can see something here. You can write it as s dy dx equals y ln y over x plus y. Here we can it's homogeneous, so we can go straight. Let y to be equal to ux. So we get s dy, sorry. So here we get dy dx to be equal to u plus s dy dx. du dx. Okay? So by substitution, by substitution. Then we can get u plus s du dx. But don't forget, the dy dx is multiplying this. So multiply this by what? S. Then is equal to y is us over ln y over s is what? U plus us. So here we get us plus s squared du dx is equal to us over ln u plus us. Now, when you send this to this side, it will cancel this. So get this will clear off. So we get s squared du dx is equal to us ln u. You see what we have right now? Very good. Now, having this, then we can see that here we can do something. And what we can do is that let's go back and check first. Sorry. By the substitution of the dy dx, here is du, here is x, but we made it s instead of u. So here will not be s squared, it is ux. Alright? So this cancels this, we will be left with ux du dx equals this. Very good. So now, having this, you can see that we can multiply this by 1 over us. Then multiply it by 1 over us. So this will cancel this. This will cancel this. Algebra. So here we get du dx is equal to 1 over ln u, 1 over ln u. So to separate, so this is separable differential. So we get du then 1 over ln u, alright, to be equal to 1 dx. Then we integrate both sides. So from here, we should be able to continue with it. I hope you can see what it is. Very good. So that is that for that. So continue from here. So that's what you're going to get for that. Now, I would like you to go and continue. I would like you to go and try on this question. In fact, we have done a lot under the case 1 and the case 2. So you should be able to go and solve these questions. So you have to know the type of method to use. Okay? Alright. So that's why you have to be doing in your integration. So now, you try on 1. X plus 2y plus 3 dx is equal to u plus 2x plus 4y minus 1 dy is equal to 0. Secondly, dy dx is equal to x minus 3y minus 7. All this over x minus 4. Go and try on it. 3 x minus 2y dx, x minus 2y plus 1 dx plus 4x minus 3y minus 6 dy is equal to 0. Alright, please, I would like you to go and try on these questions. In fact, it's not difficult, alright? I have first told you that It's not always that you get it in the form dy dx. And the homogeneous equation, before you can solve it, you have to get it in the form dy dx. So let me help you with the first one. Then I'm not going to solve for you. But what I'm saying is that with this, we have x plus 2y plus 3 x plus 2x plus 4y minus 1 y equal to 3. So you divide both sides by dx. Okay, because we have to get something like dy dx. So when you divide here by dx, here by dx, here by dx, 0 by dx is 0. So here, this cancels this. So you get x plus 2y plus 3 plus. Now here, we are going to get 2x plus 4y minus 1 dy dx is equal to 0. Alright. Then, with this, you can also do something. Alright. You can divide both sides by 2x plus 4y minus 1. And you're going to get dy dx to be equal to. Don't forget, when you divide both sides by this, here you get 0 there. Let me bring that back. So you're going to get x plus 2y plus 3 over 2x plus 4y minus 1 plus here it will go. So it will be like dy dx to be equal to 0. So when you send it to this side, you get dy dx to be equal to negative, and this negative will affect the inside. Negative of x plus 2y plus 3 over 2x plus 4y minus 1. Alright, so the negative of the inside. So that's what I mean by that. So then you start. You know the constant is in, so it's not homogeneous. Then to homogeneous. Separable. General solution. Thank you. See you in the next video. I hope you have been blessed by this. Bye bye.